work again, jj, you get a 2x plus 8. Okay, this portion. Okay, yx is there. Okay, our ds, when we translate to the dA form, is r d theta dr. Okay, formula. See, I'm teaching you the skills to create by yourself. It's not to remember. When you start remember, I don't think that you can master the skill. It's very difficult for you to master the skills unless you try to, you create, you generate by yourself. Otherwise, you just start remember. It's very, very difficult, I tell you. Okay, with that, can I calculate the S5? Yes. The S5 can be calculated based on the, 2x, remember, we are using theta and r, x is a 2 r cos theta plus 8. Okay, now this is 2r cos theta 8 and r dr d theta. Okay, and what is the dr? Dr is 3 over 0 and pi over 2 to the 0. Okay, can I swap? Yes, you can swap. You can swap. When you calculate, you will get here 18 plus 18 pi. Okay, with this, we have done almost all the portion. We have done almost all the portion except the first one. Okay. Okay, with that, now I'm going for the another portion. I'm going to teach you here also 2 ways to handle this. Okay, if I done this portion, means at least I can cover the first. Then later I'll show you how many ways to handle this. I should go for many examples, This one I cannot simply stop with the one single example. Therefore, I need to go for at least 2-3 examples to make sure that you can understand all the portion. Now I'm teaching only the cylindrical portion. Later I'll need to teach you many other polygons, okay, spherical, tetrahedron, and etc. Okay, now with this you can see we continue because we have done the first portion, because we need to go and find out the ABCD. Before I go for that ABCD, I already told you before, this is a surface. The surface is something like that. If it is the arrow can be like that, and slowly you can see that could be like this. Okay, and I did explain, we map this on the one surface, which is a straight surface, any platform that we can map into. Okay, just we can see that straight like that. Can you see that? Okay, mapping shadow. The first one, we are now going to do shadow. I'm going to show you the actual. After that, I'm going to show you how to use shadow as well. Okay, but this, before we go and calculate certain things for the shadow, I want you to understand certain information about that. This, when I shadow, the shadow must fall, all the shadow must fall into this, the surface, the actual surface must fall onto this whole. What I'm trying to say is the whole shadow, okay, the whole shadow is inside the plane. The whole shadow inside the plane. Okay, if anything outside of the plane, if the shadow is outside of the plane, you cannot calculate that using shadow. That is very important. Something is outside of the shadow, you cannot calculate, because certain things is missing. The information is not complete. Okay, the information is not complete, therefore you cannot use. For example, I give you another example before I go and calculate the last one. if let's say you look at this one, there is something, the block is something like this. Okay, if like that. Can you see, I'm trying to take this model and I try to map it on some surface, let's say. Okay, this surface is like a row, take it as a row that I'm trying to map. Okay, this one, yes, all this one, no problem. Yes. Okay, these portions are missing. Okay, you see, all here can fall into this, no problem. Up to here most probably, but these portions are not. See, it's not fall into that. See the direction of row did not cover the, maybe I call it the alpha directions. Can you see that? Very important, I'm trying to say is this. When you look for the smooth area, okay, the row, that surface here, the row can cover, okay, is something you imagine. I don't have a great pen here. What I'm trying to say is, you see, it's coming to the another cycle whereby it's not follow. Okay, this row can cover this row angle. The row angle can cover this. Okay, it can cover this. It can cover this still. It can cover this. Okay, still angle can be calculated. But this. But if it is nearly can, but if it is come to the straight, it's already 0. Why? Why the row is a 0? Because it's a cos theta. Cos theta is it's already changed, you see. Okay, you can see it's a 90 degree. Okay, 90. Cos theta 90 is a 0. Okay, therefore it's already changed. When it go outside of this, you cannot calculate anymore. Okay, remember, this is very important one. Okay, this message is very important. Before I start showing you the last portion, okay, let us calculate. I can teach you this very fast, but I know very difficult for you to understand by yourself. If you wanted to do by yourself. Okay, the last portion that we are interested to solve here is this. Okay. Okay, remember this one pointing to this one pointing to this. Okay, but can I use some model A, B, C, D? Okay, it's all shadow. Please, you need to learn the skill of shadow again, shadow rules. Okay, the shadow rules now later I'll explain to you. Okay, the first one, before I use any shadow, okay, how do we map it this? Okay, this is map of, we know x2 z2 3/2, y equals to 8. We know that is going up to the 8 here, y, no problem. Okay, what about f? F equals to 6 zi 2x plus yj xk. I'm not going to write all these units again. Okay, our interest is to calculate the surface of M f dot n ds. Okay, small, okay, small s. Okay, now we start. A, B, C, D, S1, actual. I'm going to show you two. One is a shadow, how to use calculate actual shadow, actual surface and shadow. For the actual surface, it's a little bit complex. Okay, a little bit complex. Okay, But sometimes shadow can be complex. Is there any rule of thumb to calculate the surface? You may say, oh, maybe surface might be shadow might be easier. No, it's according to rule of thumb, nothing you can comment. It depends which scenario you are solving. That's the most important. Sometimes surface can be very complex. Actual can be very complex. Sometimes shadow can be very complex. Therefore, there is no rule of thumb. You must remember that. Okay, now I'm going to use actual. Actual, in this particular case, actual look complex. Don't worry. Okay, F is a x2 z2 9 0. This is a surface creator. Remember, it's a surface creator. Okay, Z, surface creator, right? I use a surface creator. Therefore, this is a F. Can I find out the del F? Yes, 2xi 2zk. Okay, done. Wait, what is N? N is del F. Okay, F. Can or not? Can. 2xi 2zk divide with okay, power 2. Remember 2, I just take it as z2, which is, you will get here 2xi 2zk divide, this one will come out, 2 come out, and this one is what? Remember, x2 z2 is equals to 3 over 2, right? Can you see that? 3 over 2, I square root, I get a 3 back. Therefore, this one is 9, if you still cannot get it. Okay, z is a 9. Therefore, you get here 2 over 9, or you can see in simple xi zk 3. Okay, now we found the end. Okay, now our task is to go for, I'm going one by one. Okay, we need to work with this end. We just found n, now we need to calculate this. Okay, but as usual, you go and calculate this. Follow my instruction properly. Always don't go for ds yet. Solve this first, this portion, then later we can go inside here. When you do this, here zi 2, you see this one become complex. That's why next time don't bother so much about this. It's a unit lah, it's understood. It's all unit. What I'm trying to say is a unit vector. Okay, this one xi unit vector, zk vector 3. But okay, when you calculate this, because it's I and k combination, it's a go for the I. Therefore you get a 6z z x minus x z 3. Okay, so 5 x z 3. Okay. Why? Slow and steady. Can you follow? Can or not? Okay, again, just go copy this, copy step by step. Okay, for the actual steps, and how to calculate the n, and how to go for the fn. First you need to calculate the fn. Okay, what about ds? Okay, ds is r d theta dy. Why ds something is r d theta dy? Come on, you look at this one, ds, the actual here, this is dy, right? Can you see that, dy? Okay, what about this? R d theta, right? Okay, can you see that? Now you know what is this. That's why I say don't remember the formula. But we know R is 3 d theta dy. Okay, and what about x and z? Okay, x equals to r cos theta, which is a 3 cos theta. What about z? Okay lah, come on, very simple. You can imagine last time we used like a z, x and y, right? If x and y, if x is a r cos theta, z is a r sin theta, right? R sin theta. Let's say you're not very sure what's supposed to write here, okay? Because suddenly you see z, how to write, okay? Because we never learn anything about this, okay? Some students, they may say, okay sir, I confused lah, because x I know, y I know r sin theta, but suddenly z is there. Okay, I teach you now. Z is can be written as something. I just prove only. I'm not x2. Okay. Okay. Now x power 2. This can be written as 9 cos 2 theta. Right. X. Okay. Then you take out this 9. Take out 3 power 2 lah. Okay. So 1 cos 2 theta. Okay. Okay, what is 1 cos theta? See, cos 2 theta sine 2 theta equals to 1, right? That means it's a negative. 1 means it's a sign back, right? What do you get here? 3 sine sine theta. Please, during exam, I am not expecting you to do all these things. I just giving you idea. Okay, actually x is actually z is here representing the y. Therefore, you can straight away you can say 3 sine theta. Okay, you no need to show all these things. But you see, if you wanted to show also, okay, no problem. Okay, can or not? Can Okay, now we done this portion anyway. Now we're going to combine everything. Okay, when we combine together, you see f and ds is 5 over 3 xz 3 d theta dy. Okay, dy d theta. Okay, that's very important. Again, this dy is a 80, theta is a pi over 2 to the 3, is a 5 over 3, don't disturb this. X is a r, cos theta 3 sin theta is a 3 d theta dy. Combine. Okay, can you follow or not? Am I fast? Okay, take it as some time first. Okay, settle first with this. Okay, we do one by one. Just combine all together. This r is still 3. This one r directly. Okay, some of you, I just remind you again. Sir, why can I put here r? Can. Only one message to you. R is not a here dependent. We are not dependent variable for this. See, the r is not depending on dy. If dr is exists, you cannot change this to 3. Okay, the 3 is independent. The r is independent of this dy dx. You see, therefore you can straight away write that. Okay, still not get it, right? Okay, keep it for a while. Later I repeat, in which case you cannot change R. Okay, if there is a dr exists here, you cannot change this to 3. You need to write here as R. Okay, because R is depending on the dr. Okay, now in this particular case, you just bring it all in one side. Is 8 to 0, pi to the 2, 0. You will get a 45 cos theta sin theta d theta dy. Okay, cosine. How to calculate? We have done several times again. Okay, this one I just say 45. Okay, 8 to 0, 5 4 2 0. Remember, u equals to sine theta du cos theta du. Therefore, you have two options to work with this, or you don't like that, you can straight away use that. Some student did complain to me also, sir, when I use a different formula inside, I get this different these things, but in the end you will get the same solution. Okay, you will get the same solution. Please go inside and you try to solve and see. And I remind you again for this portion, this is very important to know. I put as a star. Okay, it's a half. I ask you to remember this portion. Okay, y minus x or whatever. You can cos x plus y. I repeated several times. Okay, because my class student didn't know, because previously I've gone through with them this topic very extensively, but I repeat to all of you again. Cos y sin x of sin y minus x sin y plus x. Okay, therefore when I use this cos combination of cos sine here, see this one, this 3 is very important, therefore it's a cos theta. Okay, cos theta and sin theta same, therefore 0, I get a 2, it becomes 0 sine 2 theta. Okay, since this is a online course, okay, I think you can refer any books also, no issue. Okay, with that I've done the first portion. Okay, I hope that my battery can last for the another shadow portion. Hopefully I can finish A, B, C, D S1 shadow. Okay, for the shadow again, we know from the beginning 5 3 xz. Okay, for the shadow we're going to use that. This is Fn, we calculated already. Now we're going to use the shadow portion here. Okay, you see how do we going to use shadow. Okay, shadow. The shadow, you see, is like different. Can I shadow somewhere that which all this can fall inside? There are two ways. Normally, you see here, depends where you want to shadow. X, Z. Okay, you see, I will write here the ds can be shadowed to dA and to rho. Okay, our interest is what is n going to be. Okay, what is and you can use several options to do that. I can show you several options. First option, okay, I show you the first option. The first option, if I choose end, okay, if I choose end as k inside, this one fall inside, you know. Okay, the k is here, because it's overall I'm going to represent this, right? Therefore the shadow, when I refer to the shadow, if I go and fall it on this, you see, remember this one, okay, I call as A, B, C, D. It's going to fall on this, what is this, yeah, okay, let me, A, B, C, D, E, O, right? Okay, if this A, B, C, D going to fall on the A, O, C, E, okay, it's actually K, right? Can you see that? K. Because you remember we need to refer the arrow for the actual. Arrow for the actual is referring to the Z. Maybe this one not, but we are not taking the X, you know, it's all we're going to put it together, we're going to shadow, we're going to throw everything inside on this. Okay, shadow. If this shadow fall onto this, what will happen? Okay, this is a K. Or you can choose I also, or you can choose rho as a I. Okay, let me say, let me try first one by one. Let rho to be a K. If and, okay, you see xi to the plus zk 3. Okay, therefore I get a n row. What I'll get is a xi zk 3 dot with the k. Okay, it's a modulus, you know, therefore it's a positive. Remember z over 3. Okay, this is an n2 row. Okay, similarly you try and see for the I, you will get the same. Okay, you will get the same. Therefore, what is a dA? The dA, if I choose k here at this post, here dy dx, okay, it's become dx dy, combination dA. Okay, now can I combine everything as 5? F dot to the end ds is combined 8 0 3 0 5 over 3 xz. Okay, z, no, not yet. Z, you know, z 3 over z. Here I get a dx dy. Can or not? ds, remember the ds is again dx dy divided with the z over 3. Therefore it's become 3 over z dx dy. Okay, now therefore you get this equation. Then okay, get back to the similar concept here. 3 0 5x dx dy, you get 180. Okay, done. Before the battery finish, okay, you try to combine all together and you see what you get. Okay, remember we go back again the final state where the f and ds is equal to s1 plus s2 plus s3 plus s4 plus s5. Can you combine together? Can or not? Okay, easy. You take a one by one and you just combine together. Okay, 180 s1, I already given the first one. Please combine and the solution I don't have the addition of this actually. Please complete that because we don't have much time here. Therefore, I'll do the S for the F and 2 ds. Please try to find out by yourself. I don't have here the combination. The first one is S2. I got it. S1 is what? S1 is 180. Okay, sorry. S1. Okay. S2 plus S3 plus S4 plus S5. S5. Okay, the first one is 180 already. S2 is 36. Okay, S3, please could you work out by yourself? I cannot find the papers here. Okay, then step by step. Okay, I hope that you can find out by yourself. Okay, actual case X until okay X we have what is the last one? Okay, last one is 18 plus 18 pi. Okay, if you just add up, then you will get the solution. Okay, we have done the first example successfully. I can tell you this is one of the slowest teaching because I worried you all whether we can copy or not. Okay, with this I think we need to go for another break. Okay, another break. For the another break, then I'll continue for the example 2 and 3 later. Okay, but not these things. Okay, thank you. Take a deep breathing again.